All right, welcome to the last day of new material. And actually, it's kind of a review, so we've already done it, but newish in a way. So we're going to do radicals today. We're talking about simplifying, adding, subtracting, multiplying, dividing. Okay, so let's get to work here. Remember the parts of a radical? The number inside the little check mark here is called an index. Now, this is actually called a square root. So there is a number in the index. Excuse me, we normally don't write it. It's normally a 2. That's why it's called a square root. So the square root of 4 is also equal to that, okay? So if you don't see a number in the check mark, it is a 2. Any other root, cube root, fourth root, fifth root, whatever it is, will have a number inside that little check mark, the index. The number inside the radical is called the radicand, okay? Remember, square roots are fun because they're radical. So the radicand is the number inside, and that is the number we're going to simplify. So remember, there is simplest radical form means there's no perfect squares in the radical. Okay. There's also no perfect square factors in the radical. So it should be like no doubles when you do your prime factorization. There's no fractions inside the radicand, so inside the number in the radical, and there's no radicals in the bottom of a fraction. We're not going to do that today, but we're going to go through it. So the first one is simplifying. So with simplifying, remember we talked about using our factor tree to figure out the prime factors. So 75, for example, is 3 and 25, and 25 becomes 5 and 5. So these are the prime factors. We're going to list them out in our radical. So we have the square root of 3 times 5 times 5. We circle the set of numbers. So however many numbers is the same as the index. So a square root, we want 2, we want doubles. Okay, cube root, we want triples. All right, this is 25. So when I take the square root of that number, I'm going to pull one of those numbers out, leaving a 5 in front. And then any other numbers that are inside the radical are going to stay inside. So this becomes 5 radical 3. So if you type the square root of 75, the square root of 5 radical 3 in your calculator, you should get the same decimal. All right. Likewise, we're going to simplify 20 here. So we know this is 5 times 4, and 4 becomes 2 times 2. So this is equal to 2 times the square root of, and we're going to group these numbers together. So we don't want to put 5 in the middle of the 2s. We want to do like 2, 2, and 5. Okay, or 5, 2, 2, either one. So now I'm going to do my sets again. So I do the 2 times 2 is 4. For that, I bring one number out front. So there was a 2 there already. I'm multiplying it times the 2 that I brought out, and there's a 5 left inside. So this becomes 4 square root of 5. All right, if all the numbers of the radical come out, the radical just goes away. All right, keep that in mind. And then the square root of 216, do the same thing. Now, like this one's easily, it might be hard to figure out what numbers go in, but for example, I can tell that a 2 goes in because it's even, and that would leave 108 behind, and a 2 goes into 108, which leaves 54 behind, and a 2 goes into that, which leaves 27 behind, and then 27 is like 3 times 9, and then 3 times 3. So 216 becomes, okay, 1, 2, another 2, another 2, and then 3, 3, and 3. So 3 3s and 3 2s put together. So I circle my sets of numbers, okay? I have a set of 2s and a set of 3s. So 1, 2 is going to come out front. 1, 3 is going to come out front. So this gives me 2 times 3 outside and 2 times 3 inside. So I'm going to multiply these numbers together to give me 6, and inside I get square root of 6. And that is simplest form. All right. Operations with radicals. So when we're adding and subtracting radicals, which we're going to do next, the first thing we're going to do is we're going to simplify the radical if possible. Then we're going to add or subtract alike radicals. They have to have the same number inside the radical, same radicand, same index, same radicand, okay? So just like adding x's, we add or subtract the numbers in front of the radical, and we keep the radical the same, okay? So for example, radical 20 is 2 radical 5, square root of 45 is 3 radical 5. So these are like radicals because they both have the same square root, okay? Same radicand and index. So add the 2 and 3 to get 5, and the radical 5 stays the same. All right. So let's do some adding, subtracting first, and then we'll come back to the multiplying. So add or subtract. All right, so here we go. Square root of 48, I'm going to simplify that first. So that's 6 and 8, 2 and 3, and then 4 and 2, and then 2 and 2. 27 is 3 and 9, and then 3 and 3. And then 75, we know already, is like 5 and 15, or 25 and 3, it's up to you. And then 5 and 3. And so I'm going to go ahead and do the simplified form for all the radicals first, and then I'll off to the side, I'll put what this is. So this becomes 1, 2, 3, 4 2's and a 3. Okay. This becomes 3, 3, and 3. And this one is 5, 5, and 3. And we're putting a times sign in between all these. So I have a set of 2's, a set of 2's, and a 3. So this is going to be, now I don't have to write out all the time. 2 times 2 is 4 with a radical 3. Okay, so actually we'll put a symbol going down here, plus. All right, we have a set of 3's here. This becomes 3 radical 3. Okay, and we have a set of 5's here, so plus, and this becomes 5 square root of 3. And so now when I combine my like terms, 4 plus 3 is 7, plus 5 is 12, and then the radical 3 is still attached. All right, so same thing with subtraction. So instead of adding, now we subtract the numbers in front. Okay, so 16 is 2 and 8, 2 and 4, 2 and 2, 12 is 4 and 3, and then this is going to be 2 and 2. So this is going to be equal to 6 radical, and then it's looks like it's 4 2's, 2, 3, 4, 2 with a time sign in between all of these. All right, minus 2 radical, and then we have 2 2's and a 3. So this becomes, I take the 2's and the 2's out, so both 2's. So this becomes 6 times, looks like 4, minus, and it's taking a set of 2's out, so this is 4 square root of 3. So this becomes 24 minus 4 radical 3. I cannot subtract these because this one does not have a radical 3 on it, okay? So the answer is just 24 minus 4 radical 3. That is it. All right, so getting into multiplying, okay? So go back to the front page here. When we multiply, all right, we are going to multiply the numbers in front, okay, the radicals together. We're going to multiply the numbers inside the radicals together, and then we're going to simplify. Now, if we have to multiply, like these distributive property or anything else, we're still going to keep doing that, okay? Even if we have to FOIL. So even if it's something like 3 radical 2 minus 3, right, times 2 radical 2 minus 4, this is still a situation where we're going to distribute using our rainbow method here. So, all right, we're not actually going to do that one, but that's the rule. So multiply the numbers inside, they go inside. The numbers outside stay outside, and then we simplify and then add and subtract if we can after we're done. Okay, so here we go. On to question number 3. So I'm going to distribute through. So this is going to give me 3 times 2 is 6. 20 times 5 is 100. And then minus 3 times 7 is 21. And then I have a radical 20 on the end. Now, technically, 7 is actually equal to 7 times the square root of 1. So when we're doing radical 20, if there isn't a radical, the 20 becomes our new radical, like radical 20 times radical 1 there, okay? Now, the square root of 100 is already perfect square. We don't have to bust out the simplified form with the factor tree or anything. Like, we know the square root of 100 is 10. So this just becomes 6 times 10, okay? You can always use your calculator to check square roots and see if they are going to be perfect squares. However, we do have to simplify the radical 20, okay? So we can go off on the side and do that on our own. So radical 20 is 2 times 10, and this becomes 2 times 5. So this is the square root of 2 times 5, and we're going to circle our set. So this becomes 2 radical 5. So this simplifies into 20 times 2 radical 5. Remember, the radical 20 becomes 2 radical 5 with the 21 in there. So this is 60 minus 42 radical 5. Now, what I probably should have done is included a 21 here, okay? And then had the 21, and this became the 42. So had I done this correctly, that would have been the way that I have done it, thinking back on it. But either way, okay? But we'll try to simplify it and keep it easy for ourselves. All right, take a look at number 4. So same concept, we're going to multiply here. Now there is a number in front of the radical 12. It's a 1. So a negative 5 times 1, okay? And then 14 times 12 is going to become our new radical here, okay? So this is equal to negative 5 times the square root of, and we're just going to multiply 14 times 12. All right, double checking this. And that's 168. So negative 5 times the square root of 168. And then we're going to simplify, okay? So 168 becomes 2, and that looks like 84. And then we can take out a 2 again, and that's 42. You do a 2 again, and that's 21. And then we got a 3 and a 7. So this is equal to negative 5 times the square root of, we got 2, 2, 2, 3, and 7. 2, 2, 2, a 3, and a 7. Okay? And so we're going to go ahead and simplify or circle our sets. So we have a set of 2's, and that's it. We don't have another set of numbers. So this 2 is going to come out. We're going to get negative 10 in front. And 2 times 3 times 7 is 42. And that is it. Okay? All right. Last one here is dividing radicals. All right. So when we divide radicals, there's 2 ways we can kind of do the division part here. All right. Number 1, we can take a square root with a fraction that's inside the square root, and we can break it up into a fraction with 2 square roots on top and bottom. So if we're doing the square root of a over b, I can actually make that the square root of a over the square root of b. That's one of the rules for dividing fractions here. Okay, so what we're going to do is we're going to divide the numbers in front of the radical together. Then we're going to divide the numbers that are inside the radicand, under the radical together. And then we're going to simplify, okay? And if we have a denominator, or a radical denominator, we're going to rationalize. And we'll come back and do an example of that in a second. So let's go back to the back page here. Okay, remember the rules. All right, divide the numbers in front. So 24 divided by 12 is 2. Okay, and then we're going to divide the numbers inside. 48 divided by 2 is 24. So this simplifies or divides into 2 radical 24, and then we simplify. So 24, right, becomes 2 and 12, 2 and 6, and then 2 and 3. So this is equal to 2 radical, 3 2's, and a 3. Circle my set, bring one out. So this is 4 radical 6. And there's my answer. Okay, in number 6, I have to do the top part first. So I have to do the addition of radical 98 plus radical 50 first. So it means I have to simplify both of those and then see if I can add them together. So if they have to have the same radical, same index, okay? So let's do that first. So the first thing I'm going to do is actually go down to the bottom here, and I'm going to simplify both of those radicals. So 98 is 2 and 49, okay? And then 7 and 7 for 49. So this is going to be the square root of 2 times 7 times 7, okay, over plus, and the square root of 50, right, is 25 and 2, and then 5 and 5. So we get 5, 5, and 2. So 5, 5, and 2, all over 72, which let's simplify that as well. So 72 is 9 and 8, 3, 3, 4 and 2, and then 2 and 2. So this becomes the square root of 3, 3, and then 3 2's, 2, 2, and 2. All right. And so now I'm going to go ahead and circle my sets. So I have a set of 7s, one's going to come out. A set of 5s, one is going to come out. And here I have a set of 3s and a set of 2s, so one from each. So the first radical is 7 radical 2 plus 5 radical 2 over 6 radical 2. And then I'm going to combine like terms. So this is equal to 12 radical 2 over 6 radical 2. So the radical 2's are just 1. They just go away. 2 divided by 2 is 1, so that's gone. And 12 divided by 6 is 2. So this whole thing, all said and done, just equals 2. All right. And I told you we do an example of rationalizing. So let's try 3 over radical 7. So when I'm rationalizing, okay, what I have to do, go back to page 1 here, is get rid of the radical 7 on the bottom, okay, by multiplying the top and bottom by that radical. So if I want to get rid of the radical 2 here, if it's 1 over radical 2, okay, I want to multiply the bottom by radical 2. So radical 2 times radical 2 is the square root of 4, which is 2, and the radical 2 stays in the top. This is called rationalizing. All right, so I'm going to multiply the bottom by radical 7 and the top by radical 7. And this is going to equal radical 7 times radical 7, which is really the square root of 49 over 3 square root of 7. And then this just becomes 3 square root of 7 over 7. And this is in simplified form. We'll do another lesson later on with rationalizing. You don't need to know it for today. You don't need to know it for the 8th grade stuff. So we're good from here. Okay, but we are going to do number 7. Let's get a little crazy with here. So this is our FOILing. So 2 times 3, 2 times 2 radical 7, negative radical 7 times 3, and negative 1 radical 7 times 2 radical 7. So here we go. 2 times 3 is 6. 2 times 2 radical 7 is plus 4 radical 7. Negative 1 radical 7 times 3 is minus 3 radical 7. And radical 7, negative, times 2 radical 7 is going to equal negative 2 radical 7 times 7 is 49, right? Or, remember, square root of 7 times the square root of 7 just gives you that number inside, just 7. Okay, squaring it times by itself drops the radical. So 6, here we have two like terms, so plus radical 7 minus 2 times 7, so this is 6 minus 14 plus radical 7, and this is equal to negative 8 plus radical 7. I cannot combine these together. They don't both have the same radical, so that is my answer. That is it, guys. Enjoy the rest of your day, and I will see you tomorrow. I will try to do a live stream tomorrow at some point, so I'll try to get that out for you guys, but I'll definitely have a video as well. All right, guys, have a great day.